first theme lecture will be delivered by Dr. Anil Joseph. He's my good friend and he is an active structural and geotechnical engineer, that is soil foundation, soil structure interaction specialist in India. It is having the current scope. Dr. Anil Joseph has graduated and also done post graduation from NIT Surat, and he was awarded a PhD from NIT Calicut on his work on pre-compression of soft marine clays, and from Open International University on his work and from Open University on his work on pre-stressing and hollow shell technology in earthquake resistant construction. He is the director of Geostructures Private Limited, a leading foundation and structural consultancy firm based at Kochi. He has provided the foundation and structural consultancy for more than 2,000 high-rise structures, including many landmark multi-storied and infrastructure projects in India and abroad in the last 28 years. His design of Nippon Toyota showroom at Kalamassery, then Platinum Mall at Maradu, and Lulu Grand Hyatt Hotel and Convention Center, Bolgatti Island, Kochi has won the ICI Ultratech Award for Outstanding Concrete Structure of Kerala in the building category in the year 2012, 2017, and 2018, respectively. He is the managing director of Seacons Private Limited, a construction firm specialized in the execution of pile foundations, and also the director of um, Engineers Diagnostic Center Private Limited, a firm specified in geotechnical investigation and retrofitting works. He's a he served as the National Executive Committee member of the Indian Geotechnical Society, and for about four terms, and is representing India in International Technical Committee TCT 220 on field monitoring in geomechanics, and in Asian Technical Committee ASRTC 14 on spot observation methods. He is the member of State Committee in Institution of Engineers Civil Division, Executive Committee member of Institution of Engineers Kochi Local Center, the immediate past president of Association of Structural and Geotechnical Consultants, Kerala, Vice Chairman of Indian Concrete Institute, Kochi Chapter, immediate past state president of Graduate Association of Civil Engineers, the past president of Association of Piling Specialists, Kerala Honorary Secretary of Indian Geotechnical Society, Kochi Chapter, Executive Committee member of Builders Association of India, Cochin Chapter, member of Association of Contracting Engineers, Managing Committee member of Kerala Management Association, and adjunct faculty of Albertine Institute of Science and Technology, Cochin. So this shows, the team speaker is not only a consultant, he is also an administrator, and also he is a teacher also. He is a adjunct professor. And Dr. Anil Joseph is also involved in various social activities as vice president of the Regional Sports Center, Kandavantara, Cochin, district secretary of Rotary District 3201, joint secretary of Concure Foundations, etc. He was one among the top 10. This is the recent achievement of this. He was one of the top 10 Diamond Hall of Fame, New Age Icon Change Markets 2020. So it is my privilege to invite the distinguished team speaker, Dr. Anil Joseph. Over to Dr. Anil Joseph.
Thank you, Ramesh sir, for the nice words and the introduction. It's a great pleasure for me, and I would like to thank the organizers. I would like to acknowledge the presence of our incoming National President, Narendra Samadhiya ji, our session coordinator, my close friend Ramarao sir, Tyagraj, the co-chairman of the session, and our one of the main pillar of strength in Geotechnical Society, Dr. H.N. Ramesh, who is the chair of the session, and other my dear fellow participants in the session. It's a privilege for me to present you get this opportunity and talk about And can I go ahead with sharing of my presentation?
Yeah, please go ahead.
Yeah, Anil, thank you.
Sharing option is there for you.
Yeah, yes, sir.
Okay.
Sharing option is not open. Once again.
I think Professor Ramarao, please allow him to be the host.
I think bottom there is a bar. You can use that
Yeah,
button now, sir.
yeah.
And you use entire screen. You click. Bottom bar is there, sir. Press it now.
Sir, on the right hand bottom of your screen, you can find presence now option. Then upside arrow will be there. Yes, sir.
Once
Now
again,
it
once
is.
again.
It has gone again.
At the
Professor
bottom there is a
Ramarao, how many minutes you will give?
20 minutes, sir.
Okay. Dr. Anil Joseph, 20 minutes.
Yeah, yeah.
Put it in the full screen mode, sir. They
Yeah,
can
yeah.
see you.
So once again, good morning, everyone. Yeah, I will be talking on the theme forensic geotechnical engineering. And I would like to acknowledge my co-authors, Dr. S. Chandragaran, Professor NIT Calicut, and my guru and mentor, Dr. Babuti Jos, Emeritus Professor, Kusat Cochin. So I will be covering my talk in the following heads: the forensic geotechnical engineering, what it is, about the project which I am going to present today, the story before the failure, the collapse of the touch pile system, observations, initial steps taken, review of touch pile design, and will come to the conclusion. So forensic civil engineering can be considered to be the investigation of materials, products, structures, or components that fail or do not operate or function as intended, causing personal injury or damage to property. It is an upcoming science that enables engineers to predict the possible failures. It uses the insight to find the causes of failures of the structure and to upscale understanding on how to respond to close calls and to prevent a disaster. With the requirement of service facilities like car parking and the restriction for height of building, construction of deep basement has become a necessity. Structures in the immediate vicinity of excavation, dense traffic scenario, presence of underground obstructions, and utilities have made excavation a difficult task to execute. In this context, analysis and design of deep excavation and their supporting systems are essential. The basic step which should be carried out by design engineers for deep excavations are the site characterization, selecting dimension of excavation, surveying adjacent structures, establishing permissible movements, selecting earth retaining system, selecting supporting and construction scheme, predicting the movements, compare predicted with permissible movements, alter supporting and construction scheme if needed, monitor instrumentation, compare monitored result with predicted and permissible values, alter bracings and constructions. Structural engineers work with engineered materials such as concrete and steel that possess unique and well-defined properties of density, elastic modulus, compressive strength, etc. On the other hand, geotechnical engineers deal with soil, a material made by nature or God with highly variable spatial and temporal properties. Structural designs are code-based since theoretical closed-form solutions are derived based on the given geometry, material properties, and loading. However, geotechnical designs are judgment based upon due to highly variable geometry, complex loading, and material properties that are not precisely determinable, and that's the challenge. And it's words of from the Madhav's literature. A practicing geotechnical engineer cannot provide service without the fear of a lawsuit. Service of geotechnical engineers experienced in geodesy system are commissioned to investigate such failure. Now coming to my problem which I want to share with you today is the touch pile system failure at Kochi, Kerala. So this is the project. It's a B2, B1 basement, ground and 8 floors building. We have parking in the two basements and seventh and eighth floor, and commercial floors from basement to ground to 6 floors. And they had a 9.5 meter as the bottom level of B2. So this is the location of the project in Cochin, India, and this is the specific location at the where the work was going on. The touch file system, which was designed by a leading structural engineer based out of Chennai, comprised of 337 piles of 900 diameter, extending to a depth of 30-meter depth, and 20 soldier piles of 600 diameter to a depth of 30-meter. Building piles were taken to very dense strata at 43 to 46-meter depth. Touch pile system was designed as prop cantilever to resist the lateral load, because once the propping comes, the bending moment and shear force gets reduced considerably and the economy in the design can be brought in. Touch piles were done at boundary by excavating a trench of 900 width and 1.5-meter depth in a line and level, and alternate piles were done initially and then in between the piles were done. After completion of shoring works, excavation was done in 3 phases. In the first phase, they excavated up to 2 meter. Second phase went up to 6.5 meter, and the third phase excavation was planned up to 9.5 meter. So this is the video of the site, and here you can see that what was happening. This was on the crucial day of 19th April 2018, when you can see the video which is running. It's the video taken at about 5:36 p.m. And by 7 p.m. there was a slight movement, and the wall has tilted by 20 centimeter. And they were quite worried what to do about that. They told us what has to be done as the local person. So we told that it is better to evacuate the people. And by around 8 o'clock, it started moving further, and by 9 o'clock, this happened. So that was the video of the failure which was happening, and this is the photos taken after the failure from the adjacent building. And you can see that here the foundation is getting exposed, and this is the after failure photos. And when the excavation, but like I pointed out, at 5:30 p.m. the movement happened, and 100 deflection increased. Site team sought advice, and we asked to stop the work and evacuate the people. Further shift increased to 200 along with some creaking sound, and water jets were noticed on the shoring wall. And by 9:30 p.m., the shoring piles on the southern side came down suddenly. Now, observation after the collapse. Due to collapse of the touch pile system, the nearby road and earth got sunken by approximately 3 meters on the south side of the excavated area. The lateral shifting of the piles near the earth was sunken on the southwest side of the excavated area. Building layer, the southwest corner had a slight tilt towards the east side, and cracks were noted in the building, and part of the foundation was exposed. This is indicative of the progressive failure and may lead to sudden collapse of the building. Cracks were noted at ground level in all the other 3 sides of the excavated area. The roads with pavement of interlocking tiles and differential settlement. The public utilities such as road, traffic, electricity, and water supply were adversely affected by the collapse. It also resulted in temporary halt in the working of Kochi Metro, since the structure was very close to the metro station at Kannur. So an immediate action plan was made. We were called in, we visited the site, and a committee was formed by the District Disaster Management Authority, and the job which was entrusted to us was to study the reason of collapse of touch pile system, verification of statutory government approvals, suitability of the touch pile system for further construction, and scrutiny of the initial design. So these are the steps which we have taken, and since the traffics were affected, we rerouted the public traffic. We refilled the excavated area because we feel that this further collapse is likely to happen, and the building in the adjacent area may be affected. So immediately we went for refilling the area. In fact, that same night itself, we have that dredge material out. We pumped in 50 lots of material, and there was a second collapse happened at 4 o'clock in the morning. Since we have protected the roads, so we were able to prevent the further damages to the structure. 2-layer sheet piles to prevent further soil sliding was put in. filling of inner side up to the sheet pile to counter the lateral forces. And for the forensic investigation, we conducted core test, integrity test on pile, and to improve the road, we went for coconut piles because otherwise concrete or any other pile will take long time. And we wanted to re-establish the road and service support systems were also supported using coconut pile. And the stabilization of the road was done with the help of pile. And within 5 days, we were able to get the road restarted. And additional soil investigation was done to study what has gone wrong. So this is the snaps. We have refilled the area by 5 meter to prevent the damage. You can see that here the pile has moved from the top beam, which was connecting it together. So this is the guiding beam on the top, which was stitching together, and we are there giving instructions to what to do. And this is the metro rail. You can see that, which is very close by. And this is the refilling which was done with lateritic soil immediately to balance the thrust so that there won't be further collapse. You can see that the machineries are all submerged below. This is the double, and you can see the drain was here in order to dissipate the pore pressure, and we have a drainage layer here. And the double braced sheet piling was provided, and we went for the concrete core test to ensure that what was the to find out the reason of the collapse. And 11 samples were taken, and eight from the touch pile and 3 from the tie beam. Pile integrity test was conducted, where we have taken the support of one of our co-members in the Indian Geotechnical Society National Committee, Ravigaran Vaidya, who did that for us. And pile integrity test was done on the piles to understand what was the exact point of the failure. And additional soil investigation to confirm the parameters of subsoil strata was carried out. And geotechnical and structural model at different levels was carried out to understand using classic Plaxis and STAT software to find out what was the cause of the failure. So here you can see that the integrity test happening, soil testing happening, the core samples getting recovered, the core test was conducted, and it was found that cube strength values were higher than design value. So that was not the problem. Pile integrity test was done, and we found that the piles has collapsed, in fact sheared off at a depth of about 14.5 to 15.5 meter from ground level, and length of the standing pile was found to be approximately 30 meter as per the design itself. So this is the data from the pile integrity test, which was carried immediately after the collapse. And this is, you can see that where the damages has been heavily happened. And so this is the length where the strata changes, and the damages is also noted at the points. And this is the additional soil investigation work which was carried out. So you can see that the Cochin comprises of very soft marine clay, and up to 14 to 15 meter there is no much of a support value. And we went for the modeling analysis to carry out the review of the touch pile design. So soil parameters were calculation were taken from the geotechnical data, and these were the different components which were taken. This is the pressure diagram, and the capacity of the touch pile was backward. So the dia was 900 mm, M35 was the grade of concrete, what was the steel provided we worked out, and we found that the moment of resistance of the capacity of the pile was 815 kilonewton meter. So that's the one point which I would like you to note. And then touch piles were checked at different depth of soil retention. That is when the excavation reached 5 meter, what happened, 6 meter, what happened, 7.5 meter, what happened, and when it reached 9.5 meter, what happened. So at 5 meter, we found that maximum deflection 44 mm, maximum overturning moment 350, and we have that MRS 850, so it is safe at an excavation of 5 meter. So 6 meter, it moved, deflection moved to 90 mm. So 633 there, factor of safety skill 1.3. Deflection is found to be slightly higher. Since it's a temporary structure, it seems okay. And once we move to 7.5 meter, maximum deflection moved to 179 mm. Overturning moment across the permissible capacity, not safe. Deflection and overturning movements are higher, and the bracing system of the touch pile has to come into action during this time. So the bracing system has to make it probe to transfer the behavior. So this is the system of bracing system which they have gone in. So we can see the ISMC double section of 1.2 meter beams are provided, and that is the lacing was done by 65 angle, and this is the shoring pile diameter and the soldier pile sizes. So this is the retention modeling. You can see that the three-dimensional model with the spring and the utility ratio just at the brim. So you can see that it is already very close. And when the excavation moved to 9.5 meter, we found that the deflection 400 mm and the movement is much higher than what was capable for the pile to stand. So that is 2090 kilometer meter, and deflection and overturning moments are higher, and it's not safe. So this is the 9.5 meter strata, And here you can see that the utility ratio just jumping up to the range of 3.55, 3.7, indicating inadequacy of the bracing system to take care of the loading which is going to come. Since there is failure in thrust element deflection and overtuning moments were also much higher. So the analysis result summary, finding from the analysis are the shore pile with single strut propping system used in this project is found inadequate to take the lateral forces for the proposed depth of excavation of 9.5 meter. The reinforcement of the shoring pile is found inadequate against bending with single strut propping system at top provided for the proposed depth of excavation of 9.5 meter. For excavation carried out up to 6 meter depth, the touch pile system comprising of 90 centimeter diameter piles without structuring was adequate. When depth reaches 7.5 meter, the structuring system was found to have marginal deficiency to take up the earth pressure, and it was found that for the depth of 10 meter, the provided touch piling system and structuring was grossly inadequate to take up the lateral thrust. The strutting system used was a series of truss beams in grid pattern but not orthogonal to each other. This will have a tendency to make the grid system skewed and to facilitate further yielding of the probes. Soil at current depth of excavation has turned very soft on account of water seepage. This has caused considerable weakness of the interface soil. High thrust from the shoring pile at the interface has caused yielding of this soil. Subsequent increase in unsupported length of the pile is also a reason for the failure of pile in bending. So as per the analysis, inadequate strut system, soft soil yielding of soil, high thrust from shoring pile, increase in unsupported length of pile. A second tier of strut system at a lower depth could have been helpful in retaining the touch pile system in position. So this was the suggestions of the technical committee. The team scrutinized all the approval documents needed for the project and they were found in order. If adequate bracing system with higher sections and proper balanced geometry is adopted, the present touch pile system installed can take up the lateral earth pressure due to the excavation up to the proposed depth of 9.5 meter. Diagonal cross bracing, especially of corners, have to be provided. That always we have to remember when we go for deep excavation to bring in the required rigidity. That is the most vulnerable point. It is also suggested that the setback of the building of the touch pile system near the road be increased by additional 4 meters so that the road and the public utility system remain unaffected. The committee felt that the collapse of touch pile system of the building should serve as a wake-up call to the authorities and engineers in the construction industry. It is only sheer luck and timely intervention that there was no loss of human life. There was only one building close by and it has to be dismantled now with workers in the excavated area and with buildings close by. It would have been not just a failure but a catastrophe. So the conclusions to be drawn, accurate cost analysis or work study is difficult to carry out for there is limited commonality to make comparison. Every project, though looks relatively similar from certain indicative factors, it is in fact unique in itself. A great number of random and uncontrollable variants are likely to arise during the course of work. This makes planning and scheduling difficult and our profession very interesting. The actual effectiveness of work is highly dependent on the as constructed site environments, quality of the management and the executive parties, as well as the problem solving ability of the frontline persons also seriously affect the performance and effectiveness of work. Dynamic layout arrangement is usually required for the removal of the excavated soil from the basement. This may involve forming of temporary ramp, provision of special equipment, or taking over of part of the completed building as temporary access. And thank you very much for your patient hearing.